Okay guys, we're going to do some more stuff with radicals today. So before we do that, let's just do a quick warm-up. I want you to pause the video and take a moment and try and see if you can write the numbers in order, starting with the smallest. Okay, so hopefully you gave that a shot. So remember, another word for starting with the smallest, or the math word we're going to use is we're going to say that's ascending order. Ascending order. Okay, going from smallest to greatest. So maybe when you tried this, one of the challenges you ran into was the fact that these numbers are not all in the same format. If they were all in decimal form, that would be a lot easier. So we want to go ahead and convert all of these to decimal form. Okay, specifically these radicals. Okay, so the way we're going to do that, the easiest way to do it, in this case, since none of these are nice perfect squares, is to just use the calculator. All right, so we're going to go ahead and use the calculator, and remember the second x squared button is how we bring up our square roots. So let's see. So the square root of 3 comes out to 1 point, and we can round if we want to, 1.732 ish. Square root of 15, 3.87, and we'll round that up to a 3. Remember, there's a negative out front, so negative 3.873. And then lastly, root 21. And root 30. So root 21, I got 4.583. I'm rounding up a little bit. And root 30 should definitely be bigger than the square root of 21, right? That only makes sense. And it is. 5.477. So a way that you could estimate these, if you wanted to, was, think about square roots that you know. Okay, you know that the square root of 25 is 5. So the square root of 21 should be slightly less than 5, and it is. You know that the square root of 36, root 36, is 6. So the square root of 30 should be a little less than root 36, and it turns out that it is. Okay, let's go ahead and put these in ascending order then. So first we'll have our negative 1, obviously, because it's negative, it's the smallest. And then root 3, and then 2. Okay, starting here, our most negative numbers, remember how our number line works. So negative 1, that's definitely a 0. Negative 2, negative 3, etc. So here's our biggest number, negative 4. So negative root 15 should be in the middle, and then negative 3. Lastly, number 3, looks like the square root of 21 is our smallest, with 5 in the middle, and root 30 at the end. So yesterday we talked about simplifying radicals, and this is something that, it takes time, it takes practice. So I want to do some of these I want you to do some of these on your own, but I do want to kind of recap some things that we talked about. So, remember when I write some symbol like this, remember we call this the radical. We call this number n the index. Okay, and the index tells us what kind of root. So for example, this is the nth root. Okay, or the 4th root. Okay, square roots, they have a little invisible 2 here. Okay, that's how we know it's the square root. So I'm looking for something that multiplies by itself that gives me 64. Okay, now we should know that that's 8. Okay, but the question is, what do I square to get a to the 8th? What do I square? Oops. To get a to the 8th. Okay. The long way we did it yesterday was we said count out 4 8s. A times A times A. Or count out 8 of them, I'm sorry. And then cut those 8 into 2 even groups. So it looks like we can write this as a to the 4th times a to the 4th, or a to the 4th squared. Okay, so the square root must be a to the 4th. Okay, the quicker way that we talked about doing this was we said if I'm taking a square root, I can just cut this exponent in half. And to kind of expand on that, so I'm taking a square root of some number to some power. Right, I'm going to use p for power. How about that? We said you can take that power and divide it by 2 because that's what I'm doing here. Okay. To expand on that, if you have a root that's not a square root, like a third root, a fourth root, some nth root, you're going to divide the power of x by n. So for example, if I was taking the cube root of, let's say some number, we'll go x to the 9th. And that will be x to the 9 over 3, or x cubed. All right, take a minute and try these two problems. Pause the video, work on them. Okay, let's go over what you should have gotten. So something to remember, this stuff on the outside is going to just come along for the ride. Okay, so it's going to hang out outside the radical until we're done with everything. Okay, I'm going to put the stuff that comes out of the radical in parentheses, and then I'm going to multiply it through. So the square root of 25, we should have gotten 5. W to the 6th, I'm going to cut that 6 in half, so I'll get w cubed. Okay, now the question becomes, what do I do with these w's? I know 4 times 5 is 20. Okay, what am I going to do with these w's? So I have w to the first power times w cubed. So this is, if we were to write it out long ways, 20 w to the first, and w cubed is 3 w's. So how many is that total? That's 4, so w to the 4th. Okay, an easier way to think about it is I'm just adding these two exponents here. 1 plus 3, I get w to the 4th. Let me fix this 20 for us, make it look a little nicer. All right, let's look at what we should have gotten for number 3. So square root of 100 is 10. This negative is hanging out here. So I got negative 10. I'm going to divide both of these exponents by 2. So c squared d to the 5th. If you got both of those, great job. Okay, so now we want to approximate, right? So, we're not going to have the perfect decimal for this, but we want to approximate it to the nearest tenth, the nearest hundredth, and the nearest integer. So, let's remember our decimal places. Okay, the tenths, there's 1/10. So we're going out 1 decimal place. Our hundredths, right? We're going out 2 decimal places. Okay, and the nearest integer, well, the integers are the whole number portion of any decimal. Right, so -3, 2, 17, -841, those are all integers. Okay, now we should probably use a calculator to do this. So let's see, we'll do square root 66, 8.124, and a whole bunch of stuff. So for the nearest tenth, I suppose we'd say 8.1. Nearest hundredth, 8.12. And the nearest integer, and this should make sense because 66 is close to 64, which is 8 squared. So the square root of 66, if we round it to the nearest integer, is 8. Okay, let's try 81, and we can do part C without even doing part A or B. What's 81 really close to that's a perfect square? Oh, I said it. What's 84 really close to that's a perfect square? Well, 81. Right? So I know when I round, I'm probably going to get 9. Let's try it. Second root, 84. 9.16, whole bunch of stuff. So I'm going to round. Okay, it says approximate. Right? Okay, so I'm going to round up to the nearest tenth. So to remember our rounding, if the decimal that we're rounding up to, if the number after it is 5 or higher, we round up. So this will be 9.2. Okay, nearest hundredth, 1/6. There's a 5 after it though, so we're going to round up to 9.17. And then a good question here is, are these rational or irrational? So let's recall that rational numbers right, for rational, that's anything that we can write as a fraction, where A and B are integers. Okay. Irrational is anything we can't write as a fraction. One of the things that we made note of early on, we said that irrational numbers, they never end, they never repeat. The square root of any number that is not a perfect square is irrational. The square root of any number that's not a perfect square is irrational. Are these perfect squares? No. So therefore, these numbers are irrational. Let's try a few more. Square root of 45. What do we think? Are they rational or irrational? Well, it's not a perfect square, so it's going to be irrational. Right? Root 2 plus root 6, also irrational. Why? Because root 2 is irrational and root 6 is irrational, so their sum should also be irrational. Let's see what these decimals come out to and do some rounding. So I know 45, well, it's between 36, which is a perfect square, and 49, which is a perfect square. So it should be somewhere between their respective square roots, somewhere between 6 and 7. Let's see. It comes out to about 6.7. So if we were to approximate again, I'd say this is 6.7. Okay, to go to the hundredths, we would round this 8 up to a 1, 6.71. To go up to the nearest integer, well, unfortunately, this is going to get pretty inaccurate because it's going to round up to 7. Now remember, something that we can't do is we can't combine addition under the radical. That's something we talked about yesterday. So we can't do that. That's not right. That's not right either. There we go. There's our plus sign. So I got about 3.863. 8637. So to the nearest tenths, that 6 is going to round this up to a 9, 3.9. Nearest hundredths, this 3 doesn't round up anywhere, so it will be 3.86. Nearest integer, pretty close to 4, 3.86, so it's going to round up to 4. Okay. Now for 5, we know that 6 is, or 36 is a perfect square, right? So really this is root 40 minus 6. This is an irrational number minus a rational number. We said before, hey, that result is still going to be irrational. Okay, as a decimal, what does it come out to? Well, let's see. My calculator wants to behave. There it goes. Root 40 minus 6. Make a prediction. Should be bigger than 0, should be positive, but only by a little bit. Yeah, only by a little bit. Right? 0.3245. So rounding to the nearest tenth, 0.3, to the nearest hundredth, 0.32, and to the nearest integer, the nearest whole number, well, that's going to round down to 0. Okay, so at this time, I want to take a look at some of the homework questions, homework problems. Not all of them, but some of them. We'll just evaluate a few of these. Okay, so let's see. We should know these first couple perfect squares. We don't need to talk about those. Cube root of 64. What do I cube to get 64? Well, let's make a factor tree. What's some stuff I can divide 64 by? Well, I can divide it by 4. Or you know what? It's a perfect square. I can divide it by 8. Let's do that, see what happens. What, 8 times 8? Both of these, 4 times 2, 2 times 4. Oh, and these 2's combine to make a 4. So I could write 64 as 4 times 2 times 2, which is 4, times 4. Okay, or 4 cubed. So that means the cube root of 64, or the cube root of 4 cubed, is 4. Okay, and you could check your work in the calculator, right? Let's try number 6, because that has a number, a coefficient, and a variable with an exponent. So taking a look at the cube root of 8, we'll do that first. What multiplies to 8? 2 and 4. What multiplies to 4? 2 and 2. So this means I could write 8 as 2 times 2 times 2, or 2 cubed. So the cube root of 8 is 2. Now I have n to the 15th. Now remember, we said if you have a variable with an exponent under the radical, you can divide that exponent by the index. You can divide that p by the index n. Let me write that a little neater for us. So this would be 2n to the 15 over 3, or 2n to the 5th. Okay, I bet you could do something similar here. Another interesting question here is determining which are rational or irrational, and you can do it without evaluating the expression. Remember that so when we're taking roots, if it's not a perfect square or a perfect cube, it's not going to be rational. Remember what we said here. Square root of any number that is not a perfect square, that's going to be irrational. The same holds for cubes as well. So, is 47 a perfect square? No. So we know this would be irrational. Right? You can try that with the other ones. Okay, and down at the bottom, I'm going to let you think these through. When we go over it on, I guess, whenever we meet next, there is an interesting answer for one of these. Okay, so think carefully about number 13. Okay, that's all I got for you. Thanks for watching, and I will see you when I see you.